block of mass 50 kg is pulled up a straight hill and passes through points A and B with speed 7 and 3 meters per second. Okay, this is showing us that there's going to be a loss in kinetic energy since the speed is decreasing up the slope. Okay, so slope for mass for the block 50 kgs. Okay. And the speed is 7 somewhere over here and 3 somewhere over here. This distance is 200 meters. And this is 15-meter higher than the other point. For the motion of the block from A to B, find the loss in kinetic energy. So that's going to be half times m times bigger speed, which is 7 square, minus half times m times the smaller speed. It's easier to take half and 50 common and just do 7 square minus 3 square inside the bracket, which gives us 1000 joules. Okay, this is the gain in energy. Sorry, loss in energy. Okay, then in part 2, we have to find gain in potential energy, which is again mg, and difference of height. Okay, m is 50, gravitational acceleration is 10, and the change in height or the difference in height is 15. This gives us 7500 joules. Okay. Find the work done by the pulling force acting on the string. Okay. Now, I'm going to use the equation of conservation of energy, which says work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Okay. Okay, so work done by driving force has to be found. Let's call it S. X plus loss in energy. The kinetic energy is lost. So the value was found earlier, 1000, is equals to work done by resisting force. So do we have the value of the resisting force? The resisting force is actually 7.5. So work done by resisting force would be force of resistance times the distance it travels. So force of resistance is 7.5. Distance it travels is 200 meters up the slope. So 7.5 into 200 plus gain in energy, the kinetic energy increased. That value is 7500 joules. Okay, we solve this, get the value of x, which comes out to be 8,000 joules. Okay, now, okay, next part says, part 4, the pulling force acting on the block has a constant magnitude of 45 Newton and acts at an angle of alpha degree upward up the hill. Okay, so this is 45 Newton. There's a constant pulling force and it acts at an angle of alpha up the hill. Find the value of alpha. Okay, so this component is going to be 45 cos alpha. Okay, and downwards, we have mg sine theta. And we have the resisting force, which is 7.5 newtons. Now we know that work done by driving force is equals to driving force times distance covered. Okay. We know the work done by driving force, it is 8,000, I'm sorry. We found it here. this is 8,000, is equals to the driving force is actually the cos component of the force, which is going to be 45 cos alpha, okay, times the distance covered, which is 200. Okay, there was no need of this. This was a mistake. This was not needed. Only the driving force is needed. So driving force is 45 cos alpha. Okay, now you use this and find alpha and do cos inverse and all of that. You get 27.3 degrees after rounding.